Hi everyone, welcome to the fifth video in this playlist where I am showing you how you can find the range for any given functions that you can expect in your AS level syllabus. So far, we have looked into the straight line, quadratics, and this time we are going to look into the square root graphs. And if you are following my playlist, you have already seen that how much I am relying on the sketching of the graphs and then identifying what is the range. If you haven't watched the previous videos, I highly recommend that you first watch them to better understand my techniques of adapting towards how to find the range with the help of graphs or the visualization techniques. So in the square root graphs, just like the previous kind of functions that I have explained, I'll first show you what are the things that you should be aware about and then how to plot the graph, and from the graph how you can find the range. So let's get started. So for the square root functions, I have rarely seen this kind of questions to pop up in your AS level examinations to find the range. But yeah, because square root graphs are indeed part of your syllabus, you should be aware about how to find the range of the square root functions. For that, the first thing that you require is to know how the square root of x graph looks like. It always starts from the origin and then it keeps on increasing like this. It keeps on increasing like that. It can keep on going upwards like this as the x value increases. So that is the shape of the graph. Now after this, you can manipulate this graph using the transformation of the functions rules. Okay, where you should be aware about that outside the f, if you focus, this is your stretch factor and this is the translation. And inside the function, if you look into, 1 by b is your stretch factor or the compression factor, and minus c is your translation. Remember, in the x-axis we do opposite to what we do in the y-axis. In y-axis, stretch factor is a plus d is the translation. Inside the function, that is the input, minus c is the translation and 1 by b is the stretch or the compression factor. Of course, after that there is also a reflection that can come, maybe a minus sign outside the function or minus sign inside the function. If the minus sign is outside the function, it means that you are reflecting all the y values in the negative side. So that is how the negative is going to impact on this actual graph. It is the reflection in the x-axis. If you are reflecting your y values, it is the reflection along this x-axis. And if you are having a negative sign inside, not outside, if you are having only inside, in that case, your graph is going to be reflected such that your x values are transferred to the left side. So that is how the graph is going to look like in that case. Okay, if the minus sign is inside, that is the reflection around the y-axis. Okay, the x values are getting reflected, but it is happening along this y-axis. So if you're aware about these rules, then of course you can look at the expression. Based on the expression, you can manipulate the curve, and from there you can easily find out your range. So yes, let's get started with our process of making a random question and finding the respective range from the domain that we choose. Find the range for function f of x is equal to square root of x minus 3 for x greater than equal to, let's say, 5. So for this, the first thing that I'll do is I'll know that my square root of x graph is being transformed to the right side by 3. Okay, minus 3 is inside the square root. It means there is a changes happening inside the function. So this plus c, instead of plus c you are having minus 3. So minus 3 means you're going to do opposite of that. That is, you're going to take your graph to the right side by 3 units. Okay. So the same graph I'm going to draw, but to the right side, that I'm shifting by 3 units, and the graph is going to look something like that. So let me show that to you over here. The graph is going to start when x is equal to 3 because we are moving right side by 3 units. So this graph is taken to the right side by 3 units. So the graph is going to look something like this. Now, because the domain is to the right side of 5, let's say this is 5. Output of 5 would be 5 minus 3, which is 2. So over here you are having square root of 2. This is square root of 2. And because the domain is to the right side of the phi, what is the region of interest that we are interested in the graph? It is this part. This is the region of interest. It is going up. It can forever go up. There is no end. So the highest value it can take is of course plus infinity. And the minimum value, as you can see, it can take is square root of 2, which is minimum. And therefore, if I have to write the range, my output values are always going to be greater than or equal to square root of 2. That becomes my final answer. So I hope you are able to understand the notations. If you haven't watched the second video of this playlist, it will become very difficult to follow with the notations. So I highly recommend that you first watch the second video and then come back to this one. So just to confirm the answer, I am going to plot this on my Desmos. Square root of x minus 3, and the domain is x greater than equal to 5. And the value over here you can see is 5 comma 1.414. So 1.414 is nothing but the square root of 2 only. You can check that with your calci also. It is square root of 2. So that proves that the minimum value is going to start from square root of 2, and the maximum value it can keep on going upwards. There is no end to it. Okay, there is no end. It can keep on going up and up and up and up. It increases very slowly, but yeah, it is indeed increasing, right? So yeah, that is why the answer that we have written over here will make 100% of the sense. So yes, as I have mentioned that there are not a lot of questions with respect to square root, so I'll keep it limited. I'll not teach a lot of things over here. I'll just maybe choose one more question. Let's say find the range for f of x is equals to 2 times square root of x plus 1 minus 2 for, maybe first of all I'll need to be honest, plot the graph to understand what kind of domain I can keep. But clearly in the x-axis there is only one thing, that I am shifting my graph to the left side by 1 unit. Remember, we have to do the opposite of the thing that we write inside. So yeah, I'm going to shift my graph to the left side by 1 unit, and all of my y values will be getting multiplied by 2 and then subtracted by 2. Okay, so 2 times the previous value of the y minus 2 will be the new value of the y. So let me first of all make a quick sketch. Of course, if you're not understanding what I'm explaining right now, it means that your transformations of the functions is not clear. For that yet, I haven't created any video as such, but in the future if I'll create, I'll add a link maybe in the description of this video or as a part of the I button that you can click from the top right of this video. But as of now, maybe you can rely on one of your resources that you are following for the transformation of the functions. So yeah, for now, let me show you how I will draw the graph. 0, 0 is where I have to identify that exactly where it's going to be. So my x value will be shifted to minus 1. Okay. So my square root of x looks like this, but because of minus 1 shift, it's going to look something like this. Of course, this is minus 1. Now the y value, what is going to happen to this y value? It's going to be multiplied first with 2 and then we do minus 2 to that. So of course the y value is 0, which is multiplied with 2, which will be 0. Minus 2 will be minus 2. So of course this point will be shifted down to minus 2 in terms of y-axis. So the graph is going to look something like this. Okay, and this is minus 2, this is minus 1. So your graph, as you can see, is starting from this minus 2 as the output, and then it keeps on going upwards forever like that. Now let me choose a domain from this. Let's say that the domain is x greater than 0, or maybe hmm, let's say if I keep my domain in between minus 1 and 0. In that case, of course, minus 1 is the value over here, 0 is the value over here. Everything in between that is a part of the domain. So the respective outputs over here and over here will be the region of interest. Okay, everything between that will be the region of interest. So this is what I have highlighted, and because -1 and 0 are not part of the domain, the outputs will not be part of the range. So at -1, of course, -2 is there, and when x is 0, if x is 0, square root 2 times square root of 1 minus 2, that is 2 minus 2, which should have come out as 0. Okay, so it means that of course there is a problem with the graph that I have drawn. The y-intercept is also something that we have to keep in mind. Alright, so because the graph is slightly incorrect in terms of how it looks like, but now you can see that how easily, because you are aware about sketching the graphs, you can highlight your mistakes and uh, take into consideration this kind of mistakes. So I'll just go ahead and quickly resketch my graph. Oops, yeah, never mind. I'll just write the things again. So it's going to look something like this. Let me change the color. Yep, guys, that is how it's going to look like. Okay, this was -2, this was -1, and of course the domain -1 to 0, and the region of interest becomes this part, right? This is the part, and the end values are not part of the output. Okay, once again I'll check. If I put my 0, 2 times square root of 1 is 2, 2 minus 2 is 0, so yes, output is 0. So this becomes your maximum value, 0 becomes your maximum value, and -2 becomes your minimum value. So how will you write your range? You will say that my range is between minimum and maximum. F of x will be in between. Your outputs are in between -2 and 0. Equal to sign will not come, as I've explained that the -1 and 0, which are not part of the domain, these are just the end values of the domain. So the respective outputs will also not be included in the range. It will just be the end values for the range. This becomes your final answer. Let's check it from the Desmos. 2 times square root of course I'll just delete this part so that it does not look ugly. So 2 times square root of x plus 1 and -2 outside. And the domain that we have chosen is something like this. So if I look on the graph, that is how the graph is going to look like, right? Starting from this point and then it keeps on going upwards. Let's say if I remove this part, you can see that it's looking very similar to what we have drawn over here. But in between -1 and 0, which is the domain, it's just this yellow graph that I have highlighted. So that is why if I bring the domain once again, that is how the graph is going to look like. Clearly, what is the range? The minimum value is -2. As you can see, -2 is where the graph is pointing towards, and the maximum value is 0. So -2 to 0 becomes your range, and that is what we have answered. So I hope in this video you were understanding that even though the square root graphs are not frequently asked, to be honest, I have never seen a question like that in your ES level Cambridge syllabus. But yeah, being a student of ES level, you should be at least aware about this concept which I have taught you over here. So I hope that was clear to you. Now in the next video, we'll be focusing on the cubic graphs. So I'll see you over there. Thank you so much for watching this video.